Welcome to The Explainer. I am incredibly excited to dive into today's topic with you because, honestly, we are looking at a massive, fundamental shift in how artificial intelligence operates inside the enterprise. For a really long time, large language models, or LLMs, well, they were basically just passive talkers. They were absolutely amazing at generating text, but they were essentially trapped inside their own training data. But today, we're exploring something called the agentic shift. We're going to look at how these models are transforming from passive talkers into active doers, and it's all happening through a mechanism called tool calling. Okay, let's just jump right in.
Here is our quick roadmap for today. We'll cover 1. From talkers to doers. 2. Sequential latency. 3. Parallel execution. 4. Business ROI. 5. Mitigating risks. And finally, 6. Strategic next steps.
All right, starting off with section 1, from talkers to doers. The absolutely crucial point you need to know is this. Tool calling is the ability of an LLM agent to actually interact with external APIs, databases, or custom functions to execute real-world tasks. You see, without tools, an AI is totally constrained. It has zero access to real-time data, it can't check your inventory, and there's no way it can update a customer record in Salesforce. But the very second you give an AI the context and ability to call tools, it connects to your live external systems. It completely bridges the gap between just understanding what you want and actually doing the work to get it done.
Think of it like this. A static LLM is kind of like having a brilliant advisor. It can give you some really great recommendations, sure, but it can't actually do the work for you. On the flip side, an agentic LLM, one that's equipped with tool calling, is like a top-tier executive assistant. If you ask an executive assistant to find some good Italian restaurants and check the weather for a dinner meeting, they don't just sit there and tell you how to do it. They actually search the places, check the forecast, and synthesize all those results for you. They execute complex tasks.
Moving right along to section 2, the bottleneck, which is sequential latency.
Now imagine your AI needs to pull a customer record from a CRM, grab some recent orders from a data warehouse, and check open tickets from a support desk. Well, early systems did this sequentially. The AI calls tool 1, and then it waits for the data. Then it calls tool 2 and waits for the data. You get the idea. This clunky step-by-step execution means your total wait time is literally the sum of every single tool's response time plus the AI's processing time. Those wait times stack up incredibly fast. And for a customer sitting there waiting on a chat interface, it completely destroys the user experience.
Which brings us to section 3, the solution, parallel execution. Get a load of this staggering metric, 3.7x. According to benchmarks from systems like LLM Compiler, moving your architecture from sequential to parallel execution can yield massive latency speedups. We're talking up to 3.7 times faster for specific tasks. Instead of waiting for one tool to finish before it starts the next, the LLM analyzes your prompt, identifies exactly which tools don't depend on each other, and just requests them all in one single concurrent batch. It is a total game changer.
Let's actually break down the math here because it puts things in perspective. In a sequential flow, if you have 3 tools that each take 200 milliseconds, they run one after the other. That's 600 milliseconds right there. Add in the LLM overhead, and suddenly you're at over 2 whole seconds of waiting. But with parallel execution, those tools run concurrently. Your tool execution time drops to just the duration of the slowest single tool, so a flat 200 milliseconds. Add one single round of LLM synthesis, and your total latency plummets to 700 milliseconds. You get 3 times the speed just by changing how you orchestrate the tools.
Let's look at what this means for your bottom line in section 4, real-world business ROI.
This isn't just some abstract IT upgrade. These are real-world business impacts from integrating active tool-calling agents with parallel vector databases. In healthcare, enabling agents to instantly fetch patient records and schedule appointments concurrently actually led to a 20% increase in patient satisfaction, all thanks to drastically reduced wait times. In finance, streamlining customer service by fetching account balances and transaction histories simultaneously sped up their ticket resolution by 30%. And in retail, agents that can pull personalized shopping history and apply discounts concurrently drove a 15% increase in sales. Bottom line, this directly moves your critical KPIs.
But it's not all sunshine and rainbows. Section 5, mitigating enterprise security risks.
We really need to talk about the limits and risks of naive tool implementations, because doing this wrong is dangerous. First up, credential bleed. If multiple tools share a security context, your access tokens can leak across systems. Not good. Second, API rate limits. Concurrent hits can easily trigger API throttling if strict limits aren't enforced. And third, token overhead. Sending massive, unstructured batches of data back to an LLM will heavily inflate your costs if you don't demand a very strict, specific result format from your agents.
So, that brings up the multi-million-dollar question, doesn't it? How on earth do we secure and orchestrate this at scale? How do we get that blazing speed of parallel execution without breaking our internal systems or compromising our data?
Well, the answer lies in strict architecture. Your engineering teams absolutely must implement strict session isolation. That means every single tool invocation gets its own scoped, short-lived credential. On top of that, the industry is rapidly moving towards standardized frameworks like the Model Context Protocol, or MCP. MCP is brilliant because it allows you to organize your tools by cognitive function, like perceiving data versus acting on data, rather than just throwing random API endpoints at the wall. This standardizes exactly how agents talk to your tools, making the agent's reasoning highly transparent, securely bounded by strict limits, and predictable in its result format.
Finally, let's wrap up with Section 6, Strategic Next Steps. Here are the 3 actionable takeaways you can hand directly to your teams today. Number 1, mandate parallel execution for any agent tasks pulling from multiple sources. Just don't let your users wait in line anymore. Number 2, enforce strict session isolation to completely prevent credential bleed. And number 3, adopt MCP frameworks to scale securely. This ensures your teams are providing the right context, hard limits, and expected result formats to the models. If you give your engineering teams these specific directives, you are going to build AI systems that are fast, safe, and just incredibly effective. I want to leave you with this final provocative thought. The future isn't just about AI that talks. It's about AI that acts. We are officially moving past the era of the brilliant advisor, and we're stepping right into the era of the autonomous executive assistant. The enterprises that win this race, they will be the ones that successfully hand their AI the right tools, orchestrate them concurrently, and secure them tightly. Thank you so much for joining me for this explainer. Now go out there and build AI that actually does the work.